So ladies and gentlemen, my name is Isabel van Gent. I am the program manager at STEM in Action. And we are very grateful that you are taking your time tonight to listen to what we are going to tell you. First of all, the learners, I'm very glad to see that there are so many of you, and the parents, and then there are also quite a few educator names that I just saw in between the others. Then I would also like to welcome and thank the staff of STEM in Action for helping to organize and arrange this meeting. And then even more importantly, I want to welcome Mr. Carl de Prier. He is going to be the first speaker tonight. Mr. Carl de Prier is the director of the AMTC, that is the Advanced Mechatronic Technical Center at the North Campus. And he is going to give a general talk on engineering, and after that I'm going to take you through entry requirements and the qualifications that we do offer at Nelson Mandela University. The first part of the talk is very generic about engineering in general, and then the second part is more specifically on NMU. I see there is a Galaxy A10s to everyone. Am I the only one who can't hear anything? So perhaps if someone can just help her out. There you can see Dr. Tina Sonicus from STEM in Action is going to communicate directly to you to make sure that you can hear us. Right, so at this stage, I think I'm going to hand it over to Mr. Carl de Prier from the AMTC so that he can inform you about the importance and the impact of engineering in general. While he is just getting his PowerPoint up and running, I would also just like to say that please type your questions in the chat box. I know on the computers at the bottom of your screen, there is a little icon that says chat. If you open that, you can actually type in anything there that you want to ask. We are going to look at those questions later on. You are also welcome later on after the two presentations. There will be time for questions. You can also verbally ask your questions. So I'm going to hand over to Carl now so that he can start his presentation.
Thank you, Isabel. Just an indication, can you guys hear me?
Yes, sir. Sir.
Good.
Yes, sir.
You guys can hear me. If there are any questions, Isabel, I can't see the screen that there might be hands up or so. You can just maybe stop me verbally. But good evening, everybody, and welcome to this presentation. Isabel asked me to speak on a generic approach to engineering. I'm biased obviously to engineering for you guys to study engineering and the importance of maths and science and everything else. I'm sure Isabel will highlight that as well. But I'm biased to engineering, and I think engineering is the most important area to study if you are thinking of studying after school at a college or a university or a University of Technology. Now, I'm the director of what they call the Advanced Mechatronics Technology Center. It's a center that we established about 20 years ago at our School of Engineering, where we do various things from building aeroplanes and drones, as you can see. And I'll talk a bit about that. We have women in engineering, ladies at the bottom here, where we support our students. We have some autonomous vehicles. I'll talk a bit more about that. We have automated line and various other research projects that I'll highlight to you guys. Isabel, if I'm going too fast or too slow, just give me a nudge if you don't mind.
Thanks, I'll do that.
All right, so why, and you can see my screen, Isabel, eh?
Yep.
Okay.
Thank you, I do.
Okay, so I'm not sure if you guys are familiar with what they call Maslow's hierarchy. I'm not a psychologist or in no means, I'm a mechanical engineer, but Maslow is a very clever guy. In 1943, he produced this triangle where he says normal people like us have specific needs, but we need our basic needs is to have water to eat, to have a place to rest, and to have warmth and food. That's the basic needs that we have. Once you have that, you start caring about the security and the safety of your family. Then you start worrying about your family. So as you see this hierarchy goes up, then you start worrying about, they say, they call it love needs and an intimate relationship with your girlfriend or boyfriend. Once you have the basic needs in place, then you start worrying about, not worrying, but caring about other things. And then prestige and feeling accomplished, you study and you become an engineer, a technologist, a technician. You become something that is prestigious, and you feel comfortable in life, and you've got the basic needs in place, and then what they call self-actualization, self-fulfillment needs, and you reach your full potential. And that's when they say us as human beings, as we become creative in our activities, and we can really come to our full potential. Okay, so but you have your basic needs at the bottom here. So how does this relate to engineering? And this is why I say I think engineering is the most important thing that you guys will ever study. I'm not saying you have to study with us. I'm saying that you have to study engineering for the future, for us as a human being. So what is important, and I'm not looking at South Africa, which is a small little country here, I'm looking at the whole world. What would you guys say or think is the most important thing in the next 100 years for our planet Earth? As you can see, we have obviously a couple of continents, and we have lots of people on Earth. So if I can just quickly get my slide to go move forward, for some reason it doesn't want to. But there you go. My opinion, and it's my personal opinion, if you look at, we are here at 2021, right about there, and at this stage, it looks like we are just below 8 billion people on Earth. 8 billion people, and if the current trends continue, if you look at this, in the year 2100, now that looks a long way away, it's 80 years from now. No, none of us will be alive, but your children will definitely be alive. My children will hopefully still be alive. But if this current trend continues, there will be more than 10 billion people on Earth. Now think of that triangle that I showed you in the previous slide. Your basic needs is food, warmth, place to stay. Where will all these people stay? How will they eat? What will they eat? And this is how I want to relate this to this hierarchy that I spoke about. Is if we look at our basic needs and look up to where we fulfill ourselves, or self-actualization at the top level, how does engineering impact on what I've just mentioned, 10 billion people on Earth? How or what difference would engineering make? Think about agricultural. Agricultural is in this case food, you need to eat. Civil engineering, homes. And then it starts increasing into things like aeronautical, transportation, mechatronics, electrical, mechanical engineering. And then at the end, I'll just talk very quickly about nano engineering. How engineering will change in the next, and I'll say 80 years. 80 years in engineering is a lifetime. So I want to show you what is expected to happen in the next couple of years. Now, if we talk about the first one is agricultural engineering. They talk about, we have to feed a lot of people on Earth. I'm not talking about South Africa, I'm talking about the whole world. 8 or 10 billion people. How do we feed so many people? I mean, just look at autonomous machines. You look at these harvesting machines over here. These work, look at this robot, okay? Drones doing certain things in agriculture. These are all automated machines. I've seen videos of tractors like these that are automated. There are 10 next to each other that can harvest 24/7 automatically fields like this. Okay, there's not enough people to work in these lands, but there's more than enough people that has to be fed. So if I relate this to engineering, somebody's going to design these machines. Somebody's going to control these machines so they can plow or harvest or do their fancy things, spray crops automatically so that we can feed a lot of people. So agriculture, I think in the future will be very important. But if I can relate to what we do at Nelson Mandela University in the School of Engineering, we had a PhD student here, James Sewell, he's finished now, that had designed a automated crop identification machine. This machine, if you look over here, there's a little camera in there, it identifies the difference between a crop and maybe weed. And then it has arms that can remove the weed automatically on the land. So It's got solar panels on top, and this machine walks up and down these lines. As long as the sun shines, that's James over there. Finished his PhD, like I said, last year. As long as there's sun shining, this machine will work and do what it needs to do. If you go up that triangle, we talk about homes and the dwellings that we stay in, and what the future buildings look like. For example's sake, they talk about buildings that people in certain places in the world, that they stay in a building on the top floor, they work at this level, and at the bottom here there's a pick and pay center where you can go shopping. So all these guys do is they move up and down this building. They never leave this building. Okay, that's how complex buildings are becoming. If you think about roads and renewable energy, solar energy, I talk about roads where the lines are digitally controlled. So these signs on the roads are digitally altered. They are digitally altered. So they talk about roads that can charge electric cars while they're driving. Well, cars that can be charged. So you could have, for example, like in the morning, the cars go to work. We have 4 lanes going to work, 1 lane going backwards this way. In the afternoon, these lines change, and then we have 4 lanes coming back and only 1 lane going in the opposite direction. The way that we manufacture roads, houses, for example's sake, if you talk about normal building of homes as we know it, brick homes or cement blocks, they talk about printing of homes, okay, large scale printing of dwellings of homes. There's a little example of a printer that they can actually print homes, mass produce production of homes. I say it's future of engineering, but we actually do this at our university. There's an example. Lloyd is a master's student that has built this 3D printer that can actually print, that has the technology that can print actually homes of this scale. This is Dr. Sean Poole. He finished his doctorate about 4 years ago, and he started his own 3D printing company now in Port Elizabeth, where he's designed on the left-hand side here this year. It's a 3D printer that can print any 3D object 1.2 meters, 1.3 meters high. And he actually, for his research, he did wind turbine blade design research for his PhD. And these colored print blades that you see here was printed on the printer that he designed and built. And Hendrik de Jong is also a technician in our laboratories. There's a 5 meter high. This structure that you see here was printed about 4 meters high. It's actually a wing of an airplane, a mold for the wing of the airplane, not the actual wing itself. I wouldn't fly in that plane, but the mold for a wing profile for something that we had to build. So printing, 3D printing, you can buy nowadays for 4,000 rand. You can buy a desktop printer that can print 3D models of a small scale of 150 by 200 millimeters high. Sorry, but we can manufacture, and our students manufacture and build their own 3D printers as well. If you think about engineering, like for example, like marine engineering, it's not too far-fetched to think that we haven't explored too much of the ocean. Okay, so there are a lot of emphasis are placed on research of oceans and harnessing some energy or resources from the ocean. And to design something like this is very futuristic. You can see a person standing in there to go underneath the ocean and see what's going on there. So lots of designing of submarines, for example, like to probe and explore the deepest parts of the ocean. We have, for example, say scientists that do global research on temperatures of ocean and the impact of that on global warming, and they get data of sea temperature, surface sea temperatures of the ocean from satellites, and they want to verify that data that they receive from the satellites. And what we are busy doing is we are designing, a group of our guys are designing a marine glider. This is a self-propelled glider. Okay, so it hasn't got a propeller. It glides itself by diving up and down in a cycle like this with these fins, and it self-propels it with a battery bank and a ballast system on top for the diving. And it stays underwater for months at a time. It doesn't need energy, but it gathers data for the scientists. And once it surfaces, this is the ocean top. If it surfaces, it then sends a signal to a satellite or a transponder or a drone flying around, and the data is relayed to a scientist in his office somewhere doing research and verifying data. So we're busy with this. This is the design phase. So this year we're going to start building this actual marine glider. So if you look at the future of engineering, we talk about mechanical, electrical, and mechatronic engineering. Now, mechanical, electrical, design, engineering, and mechatronics is very closely related. Yes, mechanical is a lot of design work. Electrical is electrical. Isabel will talk a bit more detail about each of these areas of engineering consist of. And mechatronics and engineering is a combination of mechanical, electrical, and integration, not a combination, but an integration of mechanical, electrical, and computer engineering. So what is the future for these three engineering as we know it? Thinking about robotics, and we're not talking about industrial robotics that manufactures automated lines, that manufacture vehicles, for example, sake, or any other product, but we're talking about robotics, and you guys have seen a lot of videos and things on these robots, humanoids, and certain things they can do, exoskeletons, and how they can assist people to walk and pick up heavy weights. These aren't futuristic as such. They are already being designed and built and tested and used in industry. We talk about a futuristic electric vehicle. You guys have seen many cars, many companies that have produced many electrical cars, flying cars even. They've already designed flight paths over certain large cities for self-propelled autonomous flying cars. I wouldn't fly the car, but the car would fly itself, for example. So the way that we know engineering 50 years from now will be completely different. If you talk about automotive engineering, this type of cars have really been built and tested and implemented in some cases as well. So at our university, we've got a unit called a ULO, and they do a lot of research in South Africa for mobilizing of electric mobility. Okay, so we don't build the electric cars, but we are busy with infrastructure development and research on how do we implement electric vehicles in South Africa. If you're going to drive from Port Elizabeth to Cape Town, I mean, the car battery lasts most probably 300 kilometers. It has to be recharged, quick charged at certain points. So the infrastructure to be able to recharge electric vehicles once we have it installed in place in South Africa is done by ULO or in assistance with some other institutions in South Africa. We have electric bikes, solar bikes. We have a fully implemented charging station for electric cars. We actually have an electric car at the university that they drive around with. So if you see this little car here with a ULO stick on the side, that's an electric car that is used by a unit at the university. They actually work with a local game reserve with their electric vehicles, and they do the battery management for these systems. So we are involved with that type of technology as well already. So if you look about transportation and aeronautical engineering, for example, like these aren't simulated pictures. These are actual pictures, or this is an actual picture of a flying car, obviously autonomous vehicle. We talk about aircrafts like planes and helicopters. Okay, so as soon as you talk about planes, it has to glide. If you talk about a helicopter, something that can hover. As soon as you talk about something that must hover, an electric vehicle that must hover, you must have batteries. Then your time that you stay in the air obviously decreases. Planes that can glide with large wings like this can stay in the air a bit longer, but as soon as you have vertical propellers like this has, then it impacts on the battery power. So they talk about vertical takeoff and landing, vertical takeoff and landing, VTOL. They talk about a VTOL, a vertical takeoff and landing machine. Now, typically that'll be an automated car that can take off vertically outside your garage, fly you automatically to your work or wherever you're going, land there by itself, and you can just get off. It's like an aeronautical VTOL Uber, if you want to call it that, but it does everything by itself. To give you an example of what we do, we have done some final year projects and some research projects where our students have built planes that obviously this is a solar driven plane that can stay in the air for long periods of time. Obviously, as long as the sun shines on the wings, it has power. They've built, and the students call this monstrosity here Franken-drone, simply because I think it looks so ugly. They called it Franken-drone. It's a glider, autonomous aeroplane. The student here, you can see, built also the autonomous aeroplane that can do the reconnaissance. It takes off from this little ramp that they build, and it goes off, and it can drop stuff off on a boat, for example, or ship that passes past Port Elizabeth, 20 km of not 20 Ks. This one's range is slightly smaller or shorter, and it drops off whatever it needs on the deck of the ship with this little plane here. This is a security drone, a drone that was built by one of our master students, security drone that can react on alarms that are activated on a perimeter of either a private dwelling or a company's concern. So we're busy fine-tuning that. This is something we built. We've been busy building this for the last year or so. It's an autonomous unmanned vehicle. It's not a vehicle, it's more an aeroplane. This is the scale model that this student built for us in his master's. And this is the 70% scale model that we are busy testing at the moment. We are not allowed to, at this stage, fly it at our university. It was within 10 kilometer radius of the airport. But we've tested it, tethered it, tied it down, and we've flown it in the labs. And we're now busy with the 100% scale model. So the wingspan is about 7 meters, 100% full scale. And this, as you can see there, under Professor Phillips' hand, and Damien, he's a drone expert, this guy here. We have another one behind one of our students there. We have 4 vertical rotors that will pick it up. And we have also 2 rotors, one here and one on the front there, you can see it, that can tilt down to help lift vertically, VTOL. And then once it's in the air, it becomes an aeroplane. This actually tilts back up, and the front one tilts back up as well. And then you have 2 propellers that can drive this as a plane. So it's a vertical takeoff machine. So hopefully we'll be flying this in the next month or 2, and we get obviously the necessary authorities to approve our flight of our plane. Okay, here's the multirotor. Here we have a student now busy with his master's, a mechatronics student that's got this a huge multirotor high endurance drone that he's built. It's about 2 meters length, and you'll see there's four propellers on the edges, and here you can see it's a tethered. We're not allowed, like I said, not allowed to fly it outside unless it's tethered. Tethered means just we've tied it down to the ground, so it can't, something goes wrong, it can't go into the air and go into the pathway of our aeroplanes from the airport side. So he's busy fine-tuning this drone that can pick up at this stage. We're hoping to pick up about 100 kilogram payload, which is a huge amount that it can pick up. The same student there is there, has taken part in lots of international competitions. You'll see here from 2008 onwards, he's taken part in competitions, international competitions. Obviously in 2020, last year, because of COVID, a lot of these were done virtually, where he had to build and design. In this case, he didn't have to build, but the previous one, they had to design and build drones and then fly it against the other competitors from throughout the world. And the last couple of international competitions, you would have to design the drone. You'll see there's the drone over there. Program it, and then they had to fly virtually through certain obstacles that were set up in Russia, for example, like in this case. So you had to, from our labs in Port Elizabeth, you had to program the drones, and they had to fly, and the drone actually had to physically fly in this environment in Russia. So it was virtually programmed from our side, and obviously once it's flown through its whatever path was required, they had to flip here, and then they had to land on this, and the guy with the least amount of time that did it, if it's a bonus stock was the flip, that guy would get the most points. And this guy, you can see only the Russians beat us in some of those competitions, but he got podium places in every competition he took part in. Like I said, one of our mechatronics students. Also, very important in the next couple of years is biomedical engineering. Like I said, we have 10 million or 10 billion people on Earth, and everybody wants to live longer. The medical advances is going to be very important. And if you think that it's not possible to operate on you from a remote site in the States, it's already been done, where people can remotely operate on people via the internet or the Internet of Things and with Industry 4.0 technology. So the technology when it comes to biomedical engineering is at this stage rapidly increasing. And as you know, we've just started a medical school at our university this year for the first time. We're starting to work very closely with that medical faculty to see how we can enhance engineering products for their qualification. The last engineering, we don't offer this at our university, but nano engineering. Nano is very small. This is blood cells in your blood. When they talk about nano engineering, they're talking about subatomic and atomic level type of engineering. And this is not as far-fetched as you might think, where they could inject you with certain, I don't want to call it robots. Well, let's call it a robot, just for explanation purposes. A little robot that does certain things, that identifies cancer cells, for example. Like it doesn't happen at this stage yet, but I can't see it not happening in future. And it identifies cancer cells and destroys it. These engineering robots at a very small scale, at these type of scales. So this type of engineering has been done for many years already at various universities throughout the world. So engineering, in my sense, or my opinion, is the most important qualification for the future of the human race. Some other projects we do some community projects, solar projects up in Greencrossmark in the Northern Cape. We've built a solar plant up there and a water pumping facility for the local community, where we pump water from the Orange River for them to be able to grow crops. So they got lots of heat up north, but not a lot of electricity, because that's a very remote sites. We have solar concentrators we built on South Campus. There's a student here for his PhD, Mo. He's from Cameroon, and he's busy finalizing his PhD, where we collect sunlight via these reflectors to the center. We warm up air, and this air gets pumped into the ground. And I can't show in this picture, but underground we have some dolomite rocks, and we heat up the rocks, and we use that as a heat storage facility or heat battery system that we preheat water, for example, say for certain purposes. We also, this is a fun student project that they come up with. Every year we build about 8 to 10 solar boats. We go race against each other at St. Francis Bay. So a lot of the students do build their own boats, and we actually get some university to compete against our students as well to build solar vehicles. These are all fun student projects. While they get bored with their research, they come up with these ideas to take their mind off their official academic work, and they come up with this case here, the Gonzo is a solar vehicle or bicycle. They took we bought 2 bicycles, they cut it up, extended it a bit, welded other pipes in it, and they put some solar panels on it and some fancy other electronics, and we go up to the north to the flat pans there in the Northern Cape, and we go, it's a fun, go test all our equipment. So what does the future hold for engineering? In my case, there's going to be an increase in demand for new technology in the future, products and materials. It's going to be exponentially increase the demand for this new technology. But what type of, if you're not sure what type of engineering do you want to go and study, what is going to be the greatest demand in the next 5, 10, or even 20 years from now? What is going to be the biggest demand? What type of engineers are they going to look at? As I said, biomedical engineering, our bodies. People want to live longer. Lots of people, certain diseases, as we all know, how to manage that and how to prevent those type of engineers or issues. Engineering, like I referred to here, engineering our existence. So how do we continue to exist on the planet where we have minimal resources? So engineering our bodies, we talk about biomedical engineering, agricultural engineering, and actually all engineering, mechanical, electrical engineering is as important there. Engineering, we all know, we've read about this in the news, saving the planet, whether you believe whether there's an increase of the core temperature of Earth or not, but to protect planet Earth, we only have one. So we are busy demolishing and breaking our Earth down. So we have to engineer a way to actually protect Earth. So engineering for faster idea sharing and fun. We talk about Internet of Things, how to share information, mass information, data. When we need computer engineers, and I've been to a couple of schools, everybody talks about coding is the future, and some big computer companies in the States say everybody must need to know how to code. You can be very clear when it comes to coding. There are lots of different types of coding, but what is required when they talk about coding? Is it the Internet of Things, sharing of big data, those type of things? Then I agree that's the way to go. Then a very interesting one as well, engineering in business. look at this. You may be surprised to learn that engineering is the most common undergraduate degree amongst Fortune 500 CEOs this is in the United States. Fortune 500 is the top 500 companies basically that makes the most money, and that changes from year to year, obviously. But engineering is the most common undergraduate degree. What these guys do, these CEOs of these multi-billion-dollar companies, they do an engineering degree, and then they'll do an MBA or a business degree after that to understand business. So they start with engineering because it helps them to develop their problem-solving skills. This is the most important thing about engineers. We solve problems. We don't create problems. We solve problems. So in my opinion, in the next 5 to 10 years, any of these engineering groups is going to be very important for us as a human, I nearly said species, as human beings. Then in closure, guys, as engineers, we were going to be in a position to change the world, not just study it. A lot of people study what we do in the world, but engineers change and make it a better place when we talk about engineers. And the big difference here, a lot of people talk about scientists and the difference between scientists and engineers. Scientists discover a new type of material or energy or new type of process, but engineers discovers a new way to use it. Okay, so we'll apply new technology. If they give us a new material that has memory capabilities, we'll apply it into a practical project that we can apply it in, and it makes a difference in every human being's life. Thanks, guys. I don't know why my screen is so full of lines. Maybe I did something wrong. But if you have any questions, you're welcome to ask us. And there's Isabel talk as well. You're welcome to ask any questions.
Thank you for the presentation, sir.
You're welcome. Isabel, you still there?
Sorry, Carl, I just forgot to unmute. I always do that. You are welcome to type your questions in the chat bar, or also to unmute yourself and ask a question. Maybe you can just put up a hand as well if you want to ask a specific question.
See, there's a question: is software engineering a good career to follow? It's an excellent career to follow, software engineering. There's a big demand. There's a new qualification at a university now called software engineering. It's a combination of our IT colleagues and electrical engineering that will offer a software engineering qualification. So yes, software engineering is, there will be a big demand on software engineers in future.
Hi, sir. Can you please elaborate on mechatronics engineering?
Isabel will go into a bit more detail.
I agree.
In her slideshow. So if you just wait a minute or so, she will dive into that for you.
Yeah, I think what I must do at this stage is go directly into my presentation, and then Cassidy, we will answer your question after that, your question about medical engineering and chemical engineering and all the others. So we will start off there. So I am going to just go into the
we can see it as well.
Right, you can see the correct view, Carl?
Perfect. So you just start the slide.
Right. Okay, so this presentation is more about the nitty-gritty of engineering and the courses that we present at our university. And I just want to applaud Mr. Alan Roberts. He first of all put this presentation together. I don't believe in reinventing the wheel. I just tweaked it here and there to be more, hopefully to be more applicable to this audience. Right. So if you were wondering what you would become after school, Sorry, can I just ask that all the other participants be muted? Thank you. So yes, then you can also consider a career in engineering. So in order to do anything in manufacturing, designing, or whatever, there's a team of engineers that's working together to make things happen. And they are all important as they have different levels of knowledge and skills that they put together to, in the end, come up with a solution to a problem or a new product to solve a problem. So we have the engineers and we have technologists. And at Nelson Mandela University, we present courses for people to become engineers and technologists. And if we continue down the line, the next level of the technicians, engineers generally do a degree in engineering. Technologists, there's two ways of becoming an engineering technologist. There's a degree and there's a diploma plus a BTech. The technicians normally have...
Sorry, did you start your presentation? It was not going, it's not going to the next one. It just started.
Let me just see, Carl, what is on your screen at the moment?
It's your second slide.
All right, sorry, let me just quickly go back. So are you still on this one that said, ever thought about a career in engineering?
No.
This one that says that Alan Roberts...
That's the one you're on at the moment, but it's not, you haven't started the actual presentation. We're only seeing, it looks like it's frozen at that point. I'm not too sure.
Right, let me quickly... Okay, Tina.
Second slide.
Let me just quickly try something here. If I...
There you go.
And now my screen doesn't change, right?
There you go. We can see yours now.
I'm just going to try and click on the things and not use the arrows. Okay, right. So let's just start again. Sorry that I spoke like a runaway train. Technology sometimes lets you down. So if you don't know what you are going to do after school, and even if you know, you can still consider a career in engineering. Can I just quickly confirm the next slide is on?
Yes, perfect.
Okay, right. So the engineering team consists of people with different skills and knowledge and on different levels in order to make things work in terms of solving a problem or getting a new product. So there are the engineers, and engineers generally do a 4-year degree course in engineering, and the technologists. And at Nelson Mandela University, we offer courses for people to become engineers and technologists. And then there are the technicians. Generally, technicians have obtained a diploma in engineering. All these 3 tiers of engineering require some in-service training, and they can all register to become either professional engineer and professional technologist or professional technicians. And the last one are the artisans, and artisans also fulfill a very important role in any engineering business or in any manufacturing business. And typically they've studied at a TVET college, and they have obtained a NATED qualification, the N3 up to N6 in engineering. So the faculty of EBET, that is where we fall under. EBET stands for Engineering, Built Environment and Technology, consists of different schools. So the School of Engineering has 5 different departments, the electrical engineering, industrial, marine engineering, and mechanical engineering, as well as a department of mechatronics. And within the School of Engineering, we offer a suite of qualifications. The higher diploma, the higher certificate in engineering. We offer 2 courses that will give you a higher certificate in engineering. Then we have the Bachelor of Engineering Technology. There are 4 different qualifications within that department, and then the Bachelor of Engineering. So how do we actually get to become or to register for any of these courses? In one of 2 ways. Either you meet the admission requirements for the Bachelor of Engineering Technology or for the Bachelor of Engineering. And please note, we will get to that later on. These 2 different sets of requirements to study any of these 2 courses. But if you do not meet the admission requirements, but you do meet the admission requirements for the higher certificate, you can then progress to either of these 2 qualifications. The higher certificate, the minimum time that you need to complete that is 1 year. The Bachelor of Engineering Technology is 3 years, and then the Bachelor of Engineering 4 years. And after this 1 year, can I just ask that every participant please mute their microphone? Thank you very much. So you can then exit after 1 year for the higher certificate, and you can start a job in the automotive industry. Actually, there are lots of opportunities in the motor industry. For the Bachelor of Engineering, after 4 years, you can graduate, or 3 years in the case of the Bachelor of Technology. Alternatively, you can go into postgraduate studies. I'll talk about that just now. And do a Bachelor of Engineering Technology honors, because this is a 3-year degree. Another year of studying would give you an honors degree. The Bachelor of Engineering has this honors degree built in. Most 4-year degrees have the honors degree built into the course. And then from there, you can progress to a master's in engineering and then a doctorate in engineering. It is very important to note that the Bachelor of Engineering Technology, the outcome of that is you become a professional technologist. Even if you do your master's and your doctorate in engineering technology, you will not be able to register as a professional engineer. You will only become a professional engineer by doing this degree, and then, by doing this degree and then do all your in-service training, even though you might have a master's or a doctorate in the Bachelor of Engineering. So I just want to point out that following this route of the Bachelor of Engineering Technology is not, and even if you have a doctorate in engineering, this is not going to allow you to register as a professional engineer. It's only the Bachelor of Engineering that will allow you to register as a professional engineer. Admission requirements for each those different qualifications. If you do the higher certificate, you must have mathematics pure or technical mathematics and a minimum of 50%. Physical science or technical science, also a minimum of 50%, and then an applicant score of 330. So please don't stress at this stage. On the next slide, I'm going to show you exactly how to calculate your applicant score. Please note that for none of these qualifications can you offer mathematical literacy. You have to have either maths pure or technical maths. The Bachelor of Engineering Technology, the 3-year degree, maths, pure or technical maths, 60%, physical or technical science, 50% is the minimum requirement, and the applicant score of 370. For the Bachelor of Engineering, you can only enter into studies for the Bachelor of Engineering offering pure maths. Technical maths is not considered as a prerequisite for the Bachelor of Engineering. You have to have a minimum of 60% in pure maths, physical science 65%, and an applicant score of 410. Right, the whole applicant score story, let's just look at that. You take 6 of your national senior certificate subjects, excluding life orientation, and you add the percentages obtained. If you are in a quintile 1, 2, or 3 school, those are normally the no-fee schools, you add your percentages obtained in 6 subjects, plus you can add 7 points for LO if you obtain more than 50% for LO, for life orientation. Let's just do an example. So if you are in a quintile 4 and 5 school, those are fee-paying schools. Say, for instance, please note that these are just arbitrary percentages that I took. Your home language, 65, your first additional language, 56, mathematics or technical mathematics, 72, physical science, 58, and whatever your subject 5 is, I just gave you 50% for that, and subject 6. If you are in a quintile 4 or 5 school, you get 0 for life orientation. If you are in a quintile 1, 2, or 3 school, you get more than 50% for life orientation, you get 7 points. You add all of that up, and that is your applicant score. Please note, I have also given a web address here at the bottom where you can go and have a look at that on the Mandela University website. So if we now go to the previous slide with an applicant score of 361, let's just quickly see what is possible for you. 360, you would be able to qualify for to study towards a higher certificate because the minimum applicant score is. You will not be able, even though you have more than, you meet the minimum entry requirements for maths and physical science, you will not be allowed to study for a Bachelor in Engineering Technology because your applicant score is less than 370 and so forth. Please note, in these admission requirements that we specified here, we only looked at the maths, technical, the maths, the physical science, and the applicant score. There are also prerequisites for language proficiency. So you must have a minimum, a certain minimum for your languages. So that is another factor that you must consider. We didn't highlight it here, but please take notice of that. Right. So the undergraduate qualifications that we offer at Nelson Mandela University are 2 certificates, higher certificates in engineering, and the one is in mechatronic engineering, and the other one in renewable energy engineering. And that is a course that started this year. And then 4 qualifications for the Bachelor of Technology Engineering, and that's electrical, industrial, marine, and mechanical. And then the Bachelor of Engineering in Mechatronics. And then there are also 3 courses offered part-time: operations management, advanced diploma in also in operations management, and the advanced diploma in quality management. So if we are now going to look at more detail of each of these courses. So if in our pursuit of qualifications, the higher certificate Let's quickly have a look at what we offer there. In mechatronic engineering, I want to draw your attention to this is an NQF5 qualification. Now, for those of you who haven't been in touch with this type of thing, your National Senior Certificate, in other words, grade 12 certificate, the level of that is NQF4. So the higher certificate in engineering actually then increases your level of qualifications by another level. So that gives you an NQF5 qualification. And as I said before, the automated manufacturing sector in Port Elizabeth and Newtownage, the automotive sector actually create lots of job opportunities for people with this qualification. And also remember, you can use this qualification, the higher certificate, as a stepping stone to qualify for studies towards the Bachelor in Engineering Technology or for the Bachelor in Engineering. The other course is a renewable energy engineering. And of course, that prepares you for a career in the renewable energy sector, mainly for solar energy, as well as for the wind energy sector. So next, the next suite of qualifications is the Bachelor of Engineering Technology. So the first one in that group is the electrical engineering, and it improves the quality of life by developing, manufacturing, and maintaining systems that generate, transmit, distribute, and ensure effective and suitable use of electricity. So it covers all sectors that involves any flow of electrons, be it on micro or macro level. Industrial engineering is all about optimizing. So they develop concepts, design systems for optimizing manufacturing processes and service. That's the one thing that I definitely learned over the years, and that is it's all about efficiency. So they look at how can systems be improved to optimize manufacturing. Marine engineering, Carl has already alluded to some of the developments in marine engineering, and basically it's got to do with the design, development, production, operation, and maintenance of anything that floats or doesn't float in terms of water. So it's of boats, ships, oil rigs, and other above or underwater structures like submarines. So this is a very comprehensive degree that deals with anything that can move in or on water. Mechanical engineering, it's the last in the Bachelor of Engineering Technology qualifications, and they design, develop, and manufacture mechanisms, structures, and machinery. So the last qualification in the range of qualifications that Nelson Mandela University offer is the Bachelor of Engineering. It's the 4-year degree. It's mechatronics, is a combination of precision mechanical engineering, electronics, and computer system. I just want to mention that in this mechatronics degree, there is quite a bit of programming and computer systems involved in that degree. And then all our engineering qualifications are endorsed by EXA, the Engineering Council of South Africa, and the BEng, the Bachelor of Engineering Technology in Marine Engineering, is accredited by the South African Maritime Safety Authority. It is accredited by the Council of Higher Education, and all these qualifications are registered with the South African Qualification Authority. And then it is very important because unfortunately, or fortunately for some people, many people want to go and work overseas, and all these qualifications, especially the Bachelor in Engineering Technology and the BN degree, the degree in engineering, are acknowledged by the Washington Accord and the Sydney Accord. So that allows you to go and work in the majority of first world countries, and they actually recognize your qualification. You do not have to do additional courses if you want to go and work in the UK, the USA, New Zealand, Australia, etc. Right, so this is what the information that I can give you today, and yeah, we hope that you would apply to study at our university. And on this page, there's some, I don't know whether you want to take it down, we can also forward it to most of our contacts. Admissions, you can only apply online, and that is the web address where you can do that. The million-dollar question for most people is, where do I find a bursary? And that is also on the website, financialaid.mandela.ac.za. And if you are in a position where you need NSFAS assistance, please apply for NSFAS in time. Don't wait until it's too late. If you want to make use of a residence and go and stay in the hostel, that is the web address where you will find that. And there is there's the web page of the School of Engineering, Facebook page, and there is a Twitter handle that where you can get more information about us. Right, so in the end, we would like to change the world with your help if you become a student in the School of Engineering. Right, let's have a look at, so you are most welcome to continue asking your questions.
Isabel?
Yeah.
I've picked up on a couple of questions while you were talking. And,
yes, please, continue, Carl.
If you don't mind, I'm going to share my screen just again to maybe answer a couple of the questions that that were asked. Just tell me if you can see my screen.
Yes, we can. I can see your screen.
I see a lot of questions asked about whether we offer chemical engineering. Somebody asked to list all the BSc qualifications that we offer. If you go to our website, it's quite an intuitive website that we have at our university, www.mandela.ac.za. Type that in, you go to this website, and if you want to see our different faculties, various faculties, what we offer, you go to faculties and schools. You just click on there, just give a second to load, and here's all our faculty. So for example, like you look at sciences, there's our engineering faculty that we fall under. So there's School of Architecture, Engineering, Information Technology, or for example, say somebody asked about sciences, Faculty of Sciences. You go to physics, for example, say biomolecular and chemical sciences. If you go to that site, for example, say you go to the menu and they will give you a list, all the qualifications that you offer. So it's quite intuitive. There's all the qualifications, all the BSc under that faculty. So you just have to go back to the faculties. Also, very nice about the website is, Isabel has mentioned, if you want to study at a university, you go to the first button on the top left, you go study at Mandela, you go down here, it's a 4-step approach. You find out what you want to do, you apply online, you get admitted online as well, and the registration happens online. All of this, the process where you are in your application, can be monitored by you as well. And there are links to all of these sites. So once you've applied and registered and you've been admitted, you can view where your application is, why it's not going forward. Everything is done online. Thanks, Isabel. I just wanted to maybe clear that with the guys.
Thanks, Carl. Can I just quickly, so study at Mandela that is where you go if you are a prospective student and you want to apply. All the admin stuff, that is at study at Mandela. And if you go to the faculties, Carl, can you quickly just go to the faculties in school again? If you don't mind opening that.
It's open, can you see it?
Right. And if you go, for instance, every faculty, if you go, if that little part in orange doesn't satisfy your needs, go to visit website, because if you click on visit website, in this case, you will find out everything about the humanities. If you can just go down to the Faculty of Engineering. Right, and there are also qualifications offered.
It's slow to load. There you go. Alexia 830, don't draw on the screen, please. So here you'll find all the information about some of the projects, about the faculty, all the details and all the qualifications as well is also listed under those. So you just have to go to each of them. You'll note their study programs, undergraduate programs, for example, and they'll list every single qualification that is offered and in this case, the School of Engineering, Built Environment and Technology. So everything is accessed from our main website quite easily.
Thank you, Carl. Thanks for that.
Then I have another question, Isabel, about chemical engineering. We do not offer chemical engineering at our university. I also had a question on
I have to
whether,
study.
if you have to study, please, you can leave. Okay, there was a question whether you chemical engineering and medical engineering is the same. You have to distinguish between medical technology. If you want to become a doctor, for example, so you can study medical direction, but medical engineering as engineering qualification, we don't offer medical engineering as such. There's no qualification that I'm aware of that is called medical engineering, but you can do an undergrad engineering like mechatronics and then specialize at your higher levels, at your master's and PhD level in the medical technology. That you can do as well.
Okay, can I just quickly, my eyes just on this. Do you have a bachelor's degree for civil engineering? Yes, there is a bachelor's degree in a Bachelor in Engineering Technology that is under the School of the Built Environment. And we do offer that at Nelson Mandela University. And then Nicholas Janssen van Rensburg also asks, what is a technologist? And do they exist in the field of mechatronics? A technologist is a person with a 3-year degree and that has registered as a technologist. So the Bachelor of Engineering Technology, that word technology that is added to the bachelor degree, that enables you to become a technologist. Please note, after your studies, you have to do certain in-service training, and a qualified person must sign off on your on the work that you've done, and then you can register as a technologist. At our university, we do not offer a Bachelor of Technology, of Engineering Technology in mechatronics, but Carl, maybe you can inform the students if you know at what other universities that can be done. We don't actually want to tell them, but we will have to.
Yeah, you're 100% correct. Technologists are the BEng tech degrees that we offer, and that's only mechanical, electrical, civil, and industrial engineering that we offer. We offer a BEng 4-year degree in mechatronics. So technologists in mechatronics, we do not offer at our university as such.
Yeah.
Yes, and I could also just perhaps add to that, sorry, Tinus, that if you do the BEng, the Bachelor Bachelor in Engineering in Mechatronics, then you can become a professional engineer.
Yeah. Sorry, there was a question about environmental engineering, if there's such a thing, and another question on software engineering, whether the university offers that.
We don't offer environmental, and again, to my knowledge, there's no such qualification in South Africa called environmental engineering. Remember, engineering behind your qualification classifies an engineering, if I call it hardcore engineering with maths and science and physics as the basis. There's no environmental engineering. The engineering disciplines that we've mentioned, mechanical, electrical, industrial, mechatronics, can all one day specialize in making impacts on the environment. We're talking engineering here, but environmental engineering as such, we don't have. Tinus, the second one was?
Software engineer.
Software engineering is a new qualification. I'm not too sure if I remember correctly. Maybe you can look on the website. It's a new qualification that was created between IT and electrical engineering. So you can do that. Mining engineering, I see another question here, Tina, sorry. Is only offered in some of the universities in Gauteng. There's no mining around our area.
Just on the software engineering or computer studies and stuff like that, I am going to get somebody from the computer department or computer faculty to come talk to you guys as well. Basically the same setup we're doing now. So that's another talk for the future we're going to do for you guys.
Right, so Uvile asked, when should we apply? The applications open in April, so only from the end of April can you, I would assume the 1st of May rather, that you can you go into that that place on the website that Carl showed you, and then you can start applying. Please note that you must upload all the documents they ask you for, otherwise you your application will just hang there in the middle of nowhere. There's a question from Baruchka about medical school. I am not sure whether the applications for the medical school have opened and whether that is has opened with the other applications. Which results should be submitted? Normally, if you are in grade 12, you submit your grade 11 results and you are conditionally accepted if you are accepted. And only at the when you get your national senior certificate results, you submit that. Any more questions, comments?
Sorry, ma'am, about the chemical engineering and the medical engineering, is it the same thing, or is it?
No, those are two different things. Chemical engineering deals with the chemical processes in manufacturing. So that's very industrial, whereas medical engineering deals with the design and the development of apparatuses, be it prosthesis, be it machines that is used in the medical industry. So it's definitely two very different qualifications. I just quickly...
There's a question from Kieran on the polymer department and polymer engineering. Also, same as Carl said earlier, there's no proper polymer engineering thing. There's degree, but you can do polymer technology and then you can do some engineering with that to get your qualification or specialize in that field, basically.
Yes, and Kieran, we are going to have an expert talking about that in most probably end of May, June, just for the whole audience. We are going to get Mr. Vanus Gerber from the Polymer Technology Department to talk about that qualification, and it would really be worth your while. It is a very sought after qualification, and for what it is worth, apparently there's lots of bursaries available and lots of job opportunities if you do polymer technology, and then you can enhance that qualification with a qualification in engineering, and you should have a very bright future ahead of you. But that we will inform you in advance about when those talks are going to be. Then Stefan Schubert asks, if your grade 11 results aren't good enough to do an engineering degree, could you use your term 1 matric results, seeing as applications open after term 1 ends? Stefan, as far as I know, your no other grade 12 result actually carries any weight but your final result. So what I can advise you to do is apply with your grade 11 results. And in the case where you want to do engineering, apply for the higher certificate in engineering, because from there you can then, if your grade 12 results are good enough, you can then migrate into one of the degree courses in engineering.
Well, there was a question about how do you submit your school report online?
Yes.
If you look at the website where we say study at NMU university, in the step 2, once you go into applying online, you actually, all of these documents of yours, your ID, your school report, everything you scan electronically, you scan it, or take a photo of it, and you actually upload that file online. So your school report online is just a scan, a photo. Even with your cell phone, you can take a photo and upload it electronically on the website. So everything is done electronically. There's also a question, I'm just going through the ones I can answer. Can you do more than one type of engineering? By law, you're not allowed to do 2 qualifications at the same time. So you can't study mechanical and electrical physically. It's not possible. But if you wanted to do mechanical and electrical together, and in 3 years' time get your first degree, that's not possible. It's not allowed. By law, it's not allowed. And physically, I don't think you'll be able to do that anyway. But you can do, for example, sake, and I've had a lot of students that does, for example, like electrical engineering for 3 years and then go over and do a mechanical engineering degree as well. We've had plenty of those type of students in the past.
Kieran asked, what field of engineering would you advise to take with polymer technology? Polymer technology deals with the production of stuff like rubbers, paints, coatings. So I would, if it was me, I would go for industrial engineering. I don't know, Carl, would you agree with that? Even electrical engineering, it's...
Yeah, I think Vaughn has always said, if you go look at that direction to do mechanical, something like that, because there's a lot of the mixing and everything else of the polymers. So to look at that, something like, so maybe combining mechanical and the polymer technology together.
Yeah, definitely.
Yes, I think that is also a question that you can ask Vanus Gerber when he speaks to you guys in a while.
Yeah, if you wanted to pick an engineering qualification with polymer technology, I would definitely say mechanical engineering would give you a good base. There's a question, can you take a higher certificate and later take the bachelor's degree of engineering? Yes, you can. You can do a higher certificate with the BEng, the bachelor's degree. You have to have a 70% average before they would allow you to apply. For the BEng Techs, you have to have a 60% average, and you must pass all your subjects first time around as well in your higher certificate. So yes, the higher certificate is a way to access further engineering degrees.
I just quickly, can you see my screen right now?
Yes, I can see it.
Okay, right. I actually just want to show, sorry, I'm just looking for a better, sorry, I'm taking a bit of time now. I'm looking for a better image than that one that was animated.
Okay, Isabel, maybe I can answer 1 or 2 more
Right.
questions.
If you can just have a look at that one there. The higher certificate in mechatronics, for instance, or in renewable energy, so if you do not meet the admission requirements to go directly into a Bachelor of Engineering Technology or the Bachelor of Engineering, but you do meet the admission requirements for the higher certificate, you can then obtain the higher certificate after 1 year, and from there you can enter the Bachelor of Engineering Technology or the Bachelor of Engineering. There are certain, Carl, maybe you can elaborate on that. There are certain minimums that you must obtain in your subjects in the higher certificate in order to meet the requirements of both these qualifications.
Yes, you have to get, for Bachelors of Engineering, you have to get a 70% average, and for Bachelor of Engineering Technology, you have to get a 60% average of all your subjects. And like I said, you have to pass that 1-year qualification, the highest certificate. You must pass all your subjects.
So yes, that is a very good way. If you have dragged your feet while you were at school, that is a very good way to actually get into the field of engineering if you do not first time meet the admission requirements.
So, well, there's another question. What is the difference? Oops, I went away now. What's the difference? Let me just scroll down. What's the difference between software engineering and software development? There's a big difference. Software engineering is software development for control systems, for example, like in electrical or mechatronics engineering, where you develop software that controls a mechanical engineering environment. Software development is, for example, like our science, computer sciences on South Campus offers qualifications where they do software development, like, for example, gaming, where you develop gaming software, we develop business software. So in the business environment, you develop software. So not in the engineering environment as such. So with the difference between software and or software development and engineering is engineers write software packages that control things that for an automated manufacturing process, for example. Say.
There was
Or maybe.
Sorry, there was a question on whether Siemens are part of the sponsors for engineering and NMMU. And another question was, does NMMU offer motor auto electrician?
Okay, Siemens is not a sponsor. They're a partner with us. They don't sponsor us financially in the sense of bursaries and things like that. That's the question. But Siemens is a big partner of our automation and control training center that we've developed over the years to train industry on PLC programming in this case. So Siemens is not a sponsor; they are a partner with us. We don't offer motor auto electrician. This is a very important question that this person asked. Remember, we are a university, or an old technicon as we call it as well. If you want to do your trades are offered by our colleges. The East Cape Midland College, PE College offer engineering qualifications like motor auto electrician, fitting and turning. They have different names now, these qualifications at the colleges. But if you want to do a trade, a typical trade, you do those at a college.
Carl, perhaps there's another question that you can answer. What's the difference between a technologist and an engineer, with their honors, and an engineer?
A technologist is somebody that, if I can just take it one step back, the old days we had the technicons. If you studied a diploma and a higher diploma and a master's after that, once you've done your higher diploma, you could qualify as a technologist. So if you do a BEng Tech degree, you can qualify as a technologist. If you do a BEng degree, typical BEng engineering degree, like they offer at other universities, and our BEng mechatronics, you can qualify as an engineer. The difference in industry, when you are out in industry working, there's not much of a difference. They do exactly the same work. To become a technologist, it just takes a year or two more practical experience before you can qualify as a technologist. I'm for example, like I was at the LP Technicon. I studied up to a master's degree. I did a diploma, a 3-year diploma, a higher diploma, and a master's degree, and I'm a registered professional technologist. Agricultural engineering is a question about giving more information about agricultural engineering. The universities do not offer specific agricultural engineering as such. Like we mentioned previously, not only agricultural engineering, but we spoke about environmental engineering. We don't offer that qualification, but agricultural engineering specialists in that field come from these base disciplines like mechanical, electrical, mechatronics. Those guys specialize in the field. So it all depends on where you're going to work one day, and what you would like to specialize in when it comes to, for example, agricultural engineering.
Right. Fatima, you are asking, is there going to be another talk for medical fields? Yes, we would like to think that we would be able to fit that in later in the year, and we will reach you by the same means as we have reached you for this talk. I think it's getting a bit late now, and I think most of you want to continue with the rest of your evening. So please, if you will excuse us, and we can again do this in the future. I just want to thank Carl and all the other people involved for being available and for answering all your questions. And I hope this has actually meant something to you and was informative to help you make your decisions. Right, so good night, everyone. I think we must say goodbye now. Otherwise, we are going to sit here and have a chat until 12 o'clock tonight, and we all need our rest. So thank you very much once again, and enjoy the rest of your evening.
Bye, ma'am.
If there's anybody that would like to stay behind and maybe ask questions or specific questions, I'm willing to stay on, Isabel.
No,
If
thank
anybody
you
wants
so
to stay
much,
behind.
Good night. Thank you.
Thanks, Carl. So guys, if you can you can type a goodbye message. So if anyone wants to stay behind, just type there, please, I need another 15 minutes or 10 minutes. All right, Ruth, Ruth and your parents, you are most welcome to stay behind. You can verbally ask your question if you want to. Just turn off your mic.
Then
Ma'am, my question was asking with software engineering. With hearing sir's explanation, I was wondering, does that mean software engineering is like coding the machines to do certain things, or is that not what software engineering is about?
Yeah, Ruth, you're 100%. I assume I'm speaking to Ruth. You're 100% correct.
sir.
Software engineering is coding. It's when I've visited a couple of schools and everybody wants to jump on this. They've heard that coding is the future. Now, coding doesn't mean, I see a lot of these Lego robots that guys start. It's a good start in the sense of to teach you the basics of coding. In other words, what you do with a mechatronics little robot, you code it with little blocks. It's not the real industrial coding, but it gives you a sense of how to code, how to write software, and the logics of the software in order to control this piece of hardware, if I can call it that, Ruth. So what happens is with coding and software engineering, a lot of engineers sit around. Just think about it. You want to send a rocket out to space. It's an autonomous vehicle that gets blasted off into space, and then a lot of things happen on the way up there. It drops off its fuel tanks, but these things happen automatically, and there must be software coding written into a platform that does those logical sequencing, if I can call it that. So every manufacturing plant, automated manufacturing plant, makes decisions by itself based on hardware on the system. So that coding that we talk about as engineers is coding, software programming that you program into what they call programmable logical controllers that control the physical environment of engineering. That's software. Software development is you can write code on your computer and at your home, and you can develop a game, a Pac-Man game. And that software package, or you can develop software development. It's also another way of explaining it. You can develop a app for a phone. App development is big. So in that app development, if you want to create a new app, that's software development. That's also coding, but it's not engineering coding. It's an IT coding. It's an information technology coding platform. I don't know if that makes sense.
Yes, sir. So then would computer engineering be similar to software engineering or software development?
No, software engineering. Computer engineering will definitely be software engineering, not software development.
Thank you, sir.
You're welcome.
Right. Anyone else who wants to ask another question?
Yes, ma'am. I just want to ask, my goal is to study
Thank you.
mechatronics engineering. So can I just ask, I understand that it's heavily reliant on what company you work for, etc., and in what department, but I want to be a global player and work on an international scale, say one day work in Singapore, the next day in Oslo. Would mechatronics engineering be a way for me to do that?
Sorry, guys, if I can answer that, Ryan.
Yes, please. I was waiting for you to answer that one.
I can guarantee you with mechatronics degree, with the 4-year bachelor's degree, you can select where you want to stay, where you want to go and work. I have relatives that are in New Zealand, and he says he will employ everybody that is mechatronics qualified. There's such a big demand for mechatronics engineers, because mechatronic engineers can do from mechanical right through to software engineering, the whole field. And that's the way. So to answer your question in short, is that it's a global qualification. Our students work throughout. We have exchange programs with companies in Germany. Our students work out in Europe. They work in North America. They work throughout the world. It's the fact that South Africa is not a closed country anymore. We're a global player. We have to train for global employment.
And as I said, Ryan.
Thank you very much, sir. I appreciate it.
Yeah, the Washington Accord actually allows you with your qualification, just like that, into other countries without having to write any other admission exams. And if you want to become a global player with that qualification, the qualification will do its own thing if you do your thing. So it depends on you and your work ethic, whether you will become that global player with that qualification.
Appreciate it, ma'am. Thank you.
Any other questions?
Ma'am, I see there's a question in the chat asking, does mechatronics branch into nanotechnology?
If you do the basic, or the BEng 4-year degree in mechatronics, you can specialize in any engineering field after that, whether it's becoming a specialist in nanotechnology, biomedical engineering. You can select, depends on where you want to go and work, and obviously where you can find work. The economy at the moment in South Africa is not very strong, but if you find a company that designs bioengineering hardware, you can go and specialize. Mechatronics engineering is the base qualification for any engineering specialist field. So yes, nanotechnology, you could go and study your master's at MIT in the States on nanotechnology if you're finished with a mechatronics degree with us.
I think what we must understand is a lot of these specialist jobs like nanotechnology, like biomedical engineering and all of that, you have to have a certain basis, and the degree in mechatronics is an excellent basis for that. You first need those basics before you can actually go into any specialist direction.
I see there's a question, is hardware engineering a type of engineering? No, hardware in mechanical is different to hardware in electrical, is different to hardware when you talk IT, the technology qualifications. So there's no such thing as a hardware engineering. Yes, there's a question on are we planning for software engineering? Yes, it's in development. I just quickly went to the website just now to see if they've advertised that qualification yet. I was on a meeting a couple of months ago where they spoke about it, the software engineering, but it doesn't look like it's on the website as yet. But hopefully they'll have it on by the time applications open, and we can have it next year.
Sir, if we want to do research more on these engineerings, is there a certain website you would suggest we go to, or would we just search in Google?
Yeah, search in Google if you want to. I don't particularly like to Google everything, was get to sites that don't really give you the true facts, but you can go to various universities. You can go to our university on the different engineerings. You can visit a lot of other university websites that they talk about the different types of engineering. But you can simply Google mechanical engineering or electrical engineering. There's lots of information on technically the differences between all of them. So yeah, there's lots of information available online. Okay,
thank you, sir.
There's a question here. Lupelo asks, is there a medical studies course at NMU? The medical faculty just opened this year for the first time. Isabel, you must just correct me if I'm wrong. They only had place for 60 students for the medical degree, and there was nearly 8,000 applicants. Nearly 8,000 applicants for 60 positions.
Yes, you are quite right, Carl. And then someone else asked earlier on whether there's a medical school on each campus, and the answer to that is no. The medical school is only situated on the Missionville campus, and there's medical technology, yes, and there's health sciences, some other health sciences courses on the other campuses, but medicine, as in MB-CHB, is only offered on the Missionville campus. Right, ladies and gentlemen, I think at this stage, it seems that all the questions have been asked, and I think we can stop the meeting.
Thank you, ma'am, and sir. Have a lovely evening.
Thank you, and good night to everyone. And thanks again, Carl, for your patience and your availability. It's much appreciated.
No worries, Isabel.